and something that you'll see quite a bit of. And it actually allows us to do some pretty powerful things, some of which almost violate, at least on the surface, things that we've talked about previously. So let's get underway here. By the way, everyone can see me, right? Can see my screen and hear me? Perfect. Cool. Okay. So yesterday we talked. Yesterday we talked about how when we take a function, we're able to pass it into other functions. And so the point I want to make here is that if functions are like any other data type of JavaScript, then the same way that we use functions in terms of passing it in should also be the same way that we're able to use functions when we pass it out. And so here's a really simple example of a function in which we were able to create a function and have that function return a string, right? Nothing special. Hopefully everyone's very comfortable with how this looks. The point I want to make here is that if functions are able to return traditional values, then that means they can also return other functions as well, right? So here on lines 1 through 3, I create a function called greetMe that console logs out hi. On line 5, I have a function called getGreeter, and on line 6, I return greetMe. Really, really important nuance here, right? Notice how on line 6, I have return greetMe. There's no open and close parentheses after greetMe, and that's extremely important. Because if there was an open and closed parentheses after greetMe, that will mean I am trying to run or invoke greetMe as a function, and I'm returning whatever that function returns, right? However, as of right now, because I don't have the open and closed parentheses after greetMe, all I'm saying is, hey, return greetMe as a variable. And actually, if I didn't know, if I can't see lines 1 through 3, I actually have no idea what greetMe is, right? greetMe could be a number, it could be a boolean, it could be a string, or any other data type. To me, it's just a variable. And so here on line 9, we have this let greeter equal get greeter. And notice how on line 9, on the right-hand side of the equal sign, we are invoking get greeter, right? We have get greeter with an open and closed parentheses after it. And so that means on the right-hand side of line 9, we invoke get greeter, and that returns this variable called greetMe. And so on line 9 then, it simplifies down to let greeter equal the variable greetMe, right? And then now if we do type of greeter and we look at greeter, and then on line 13 we actually invoke greeter, the first console log type of greeter, well, because now the greeter variable is equal to the greetMe function, the type of is a function. If I console log out greeter, I get that printout on line 2 there. Just a quick caveat, on line 2 there, that's just the way that JavaScript, or rather that's the way that this implementation of JavaScript prints out functions. Those brackets around functions does not mean that we're putting it in an array, right? So those brackets are, in this context, does not mean array. It just means, hey, here's how I print out a function. And then last but not least, on line 13, we actually invoke the greeter function, which basically, because greeter is equal to the greetMe function, invoking greeter on line 13 is the same as invoking greetMe, and I console log out hi. Any questions here? Cool. So if we do what I said earlier not to do, right, which is here on line 6, if you notice how now on line 6, rather than saying return greetMe, I'm not returning greetMe, but I have an open and closed parentheses after it, which means I'm trying to invoke the greetMe function. Well, what happens when I invoke greetMe? On line 6, I can't move on until I finish resolving greetMe, and so I go to line 1 now. On the greetMe function, I invoke greetMe, I console log out hi, and then I'm pretty much done, right? Now, one thing to always keep in mind, and this is something that I've said before, you'll hear me say again, is even more so when we do the recursion. The lessons on recursion is every function in JavaScript will return something, and by default, that return value is undefined. And so in this case, in the greetMe function between lines 1 through 3, we don't have a return statement, which means we haven't told this function what to return, and so by default, this function is going to return undefined. And so therefore, on line 6 there, when we go back to where greetMe was, when we invoke greetMe, we get back undefined. And so on line 6, that essentially boils down to return undefined. And so now on line 9, if I was to actually invoke the getGreeter function, on line 9, the right-hand side of the equal sign takes me now to line 5. Line 5 takes me to line 6. Line 6 takes me to line 1. I invoke greetMe. I console log out hi. I return undefined. I go back to line 6. which becomes return undefined, and then therefore that returns me back to line 9, and line 9 boils down to let greeter equal undefined. And so my console log out type of greeter, when I console log out greeter, and when I invoke greeter, when I do type of greeter, I get back undefined, right? Oh, and by the way, the console log, the hi that we see printed out there, that gets printed out on line 2 when you invoke greet me. So that's where that comes from. Anywho, so on line 11 we have type of greeter, and because greeter is now undefined, type of undefined is undefined. If I console log out undefined, I get undefined. And on line 13 now, when I try to invoke the greeter function, JavaScript will say, hey, you can't invoke greeter because greeter is not a function, it's undefined, and I cannot invoke undefined. Okay, so that doesn't mean that we never invoke a function before we return it on line 6. It just means you want to be very, very careful whenever you return a function. You want to be very, very careful that you're returning either the function itself or you're returning what the function returns. Those two are very, very different things, and so you might choose one over the other depending on the instance, but you just always want to be clear that is what you intend to do. So if kind of going off this idea that I am now able to take a function and return it out of a function like I would any other value, well, then I can actually kind of apply other principles that we've learned as well, right? Here I'm actually trying to apply some very quick details around scope. Specifically, on lines 1 through in this getGreeter function, on lines 3 through 5, I create a function called greetMe, which just console logs out hi, and on line 7, I return greetMe as a variable. On line 10, when I say let greeter equal getGreeter, well, if I invoke getGreeter on the right-hand side of line 10, then getGreeter basically goes through. It takes me to line 2. Lines 3, 4, and 5, I create a greetMe function. On line 7, I return the greetMe function. And so line 10 boils down to let greeter equal, in this case, the greetMe function. And so when I invoke greeter, I get back hi. Right, so this looks almost identical to what we saw before, except now we're creating the greetMe function inside of the getGreeter function as opposed to outside of it. And that works, right, because scope allows us to look at our own scope and outwards. Here we're actually moving the greetMe function just to a closer spot to where we're actually returning it. Any questions so far? All right, cool. If this makes sense to everyone, then I'll just keep going. Okay, so one thing to also note here, and you've probably seen the arrow syntax in a little bit, and you've probably seen the arrow syntax in some of the solutions as well. But regardless of whether or not we use the arrow syntax, it's not the most important thing here. The important thing here is that we're actually also able to return anonymous functions as well, right? Anonymous functions, just as a recap, are functions that we don't name, so we don't store it in a variable name, and usually anonymous functions are meant to be used right away, right? So in our previous example, you saw us create the greeter function and then use it a few lines later. Here we're creating an anonymous function and then returning it right away. And so all this means for us is that everything else works the exact same way, except now on line 3, rather than storing that function in a variable first, now I'm just returning it directly. Okay, so whether or not a function is anonymous has no bearing on how we use it. In both scenarios, we are able to use it like we would any other variable or any other data type value in terms of we can feed it in or return it. Okay, so so far we've talked about functions that have been pretty vanilla, right? That they're just things that we can pass in, we can call, and then it will return something to us. And really, that is the kind of the takeaway here, right, for us, is this idea that these functions are not special, right? We're using them in new ways, yes, but they're still the same old kind of plain boring functions that we've been dealing with, throughout the entire course of this curriculum. As we all know, functions oftentimes take in parameters, right? They take in values that we give to it, and so if these are just plain vanilla functions, then the way that we incorporate variables in our functions is identical as well, right? Here on line 3, I return a function. Once again, this is an anonymous function because I don't have a name there. And notice how here this anonymous function that I created, it's an anonymous function, but it doesn't use the arrow syntax. Proving once again, the arrow syntax, it is more of a shortcut. It doesn't inherently do anything, at least in this curriculum, that we care about, that we can't do ourselves. In any case, I go back to this function, and this function takes in a variable called name, right? And within the function is console logs out hi name. And so on line 8, when we invoke getGreeter, getGreeter is going to return that function to us, which we store in the variable greeter. And then on line 10, when we invoke greeter, it's basically us invoking greeter and passing in the string Marie. That's the same as us invoking the function that we created on line 3 there by passing in Marie as a variable name. And so when I do Marie, Rosalind, or nothing, my console logs are going to show as hi Marie, hi Rosalind, and once again, we see kind of the tricky undefined there. Remember, in a parameter, if you don't provide a value and JavaScript is expecting a parameter, then JavaScript will store that value as undefined by default. And so that's why here it says hi undefined, because the name parameter has not been defined yet, even though it has been created. Okay, so this just means that the functions that we've been doing everything with here, they're the same as every other function that we've ever used, right? You can pass in parameters, you can return things too. Okay, I'll pause here for 30 seconds to see if there are any questions before we move on to the idea of closure. Anything at all? Cool. All right then. Okay, so let's talk about closure, right? So closure is basically an implementation, or rather, it's very closely related to this idea of scope. And so if I was to do a really quick recap on scope, just remember, scope just means, hey, we can use variables that are in our scope, that are in our parent scope, that are in our parent's parent scope, etc., all the way until we reach the global scope. Okay, what variables can we not use? We cannot use any variables in scopes that are we will call child scopes. So scopes that are inside of us. And also, we cannot look in anything we call our sibling scopes, which means scopes that are at the same kind of scope level as we are, but don't exist in our own scope. Okay, so here under my greeter function on line 6, I create a variable called name. I set it equal to Marie. On line 8, I have a function called says hi, and I console log out hi name. And then on line 11, I invoke says hi. When I invoke says hi, it takes me to line 9. It says hi name. So I look for the variable called name in my own function scope between lines 8 through 10. I don't see anything. So I look in my parent scope, I look for name, I find it on line 7, and therefore I print out hi Marie. Okay, so this should be a very straightforward refresher on how scope works. One of the reasons why we talk about closure in this idea, in this section of talking about higher order functions and relating to scopes, is closure is actually here we call it a fact, but it's almost like a principle or a concept that basically says, hey, when you're outside of your parent scope, you actually are still able to still get access to the variables in that scope. Put another way, it basically means that the scope of a function is determined based on where it was created, not on where it is used. And so let's see that in action. Here on line 1, I have a function called getGreeter, and all it does is console logs out getGreeter is running. I create a variable called Marie. I console log out getGreeter is finished, and I return this anonymous function that console logs out hi name. Okay. Now, oh sorry, this was a comment I made before. Okay. So if I was to look at this, so if I was to go through this now, on line 13, I'm forced to invoke getGreeter, which is going to console log out getGreeter is running, create a name variable, console log out getGreeter is finishing, and return this anonymous function that I will store under the variable greeter. Okay, so far so good. And then on line 14, I am going to invoke greeter, which basically this is the same as me invoking that function that I created on lines 8 through 10, right? And indeed, I see getGreeter is running, getGreeter is finishing, and then lastly, hi Marie. Now, that sounded straightforward when I kind of verbally talked through it, but notice how, in a very kind of surprising way, right? Notice how on line 14, when I invoke greeter, greeter is the same as the anonymous functions on lines 8 through 10, right? So I'm invoking greeter on line 14. However, greeter, in this case, or that anonymous function, makes use of a variable that was created on line 4, within the scope of the getGreeter function. Now, everything that we've learned up to this point has kind of told us, hey, if you're outside of the getGreeter function scope, so if you're outside of lines 1 through 11, you are not able, or you're not permitted to use any variables inside the getGreeter function. However, in this case, we actually see that that's not true, because on line 14, when we invoke greeter, we're able to print out hi Marie, and Marie is a name variable that was created inside the getGreeter function on line 4. And so the question is, why is that? Well, remember, once again, hopefully this kind of makes the point a bit clear. Scope for a function is determined based on where the scope was created, not on where it is used, right? And so here in this case, even though we are using this function on line 14, the scope for that function is always going to be based on where it was created, and it was created on line 8. And so as far as this function is concerned, its scope will always be the scope of it will always act as if its scope started on line 8. So it would always have access to the getGreeter scope as well as any parent scopes that getGreeter is a part of. Okay, and so that's basically closure in a nutshell, right? We call it closure because the idea is like the scope kind of encloses upon the function or upon the variables. But once again, like the way I think about it, that I think makes a lot of sense is just to say that, hey, look, the scope for a function is based on where it was created, not where it is used. And so if a function was created with access to a certain scope, no matter where I move this function, no matter who I give it to, no matter where I use it, it will always have access to the original scope that it was created in. Sorry. So actually, so before I go on, any questions here on this page?
One question.
Yes, so, I knew waiting was right.
Yeah. So does this mean that anytime if I inside of function greeter, getGreeter, I mean, anytime I create a variable there, it will always be available in the inside function?
Yep.
Okay. I don't have to actually have that parameter listed inside function. Okay.
So that's a good question. So notice how on line 9, that's not a parameter, right? Like that's just a variable, right? Because the function by itself takes in no parameters, right? On line 8, there's nothing in between the open and closed parentheses. So your intuition is correct, right? Like if inside that function on line 9, we will have every access. We will have access to every variable that was created in the getGreeter function. But the only thing to be careful about here is just that, we have access to every variable, but we need to kind of predefine it ahead of time, right?
But doesn't that mean then that wasn't the whole concept of scope so that things are only being used in certain places? Like now, if I have 15 variables in the function getGreeter, I'm only using one of them in the inside function. I'll still have to have all of them available at line 14.
I see. Yep. So notice how on line 14, right, when you invoke greeter, you're basically invoking the function on lines 8 through 10. On lines 8 through 10, that function has access to all 14 variables, but in the body of the function, if you don't use those variables, or if you don't define them as being used there, then that function won't use them, right? So let's say here on line 3, I create a variable called let David equal 1, 2, 3. If I keep everything else the same exact way, by the time I get to line 14, because the variable David was not used in the greeter function that I defined on lines 8 through 10, even though that function has access to David, because it wasn't used at that point, the value wasn't being stored. And so this kind of it ties in somewhat nicely with yesterday's, or rather with Monday's lesson on pass by reference versus pass by value. In reality, what's happening here is what we're saying is, hey, on line 9, when I say hi name, it basically looks for the name variable, and what it does is it will actually look for it based on where it was created from, and it'll copy that value over, right? And so if I have other variables inside getGreeter, but I don't make use of it in my return function, then it doesn't mean that everyone else still has access to those 14 variables. I only have access to the variables that were created in the getGreeter function that I used in my own function, which in this case is just line 9.
Okay, that makes sense.
Yep. Cool. So, if that's the case, then I'm not going to kind of beat a dead horse here, right? But once again, on line 2, we have this getGreeter function that takes in a name. And on line 3, I did this as a comment just so you kind of, everyone remembers that this is kind of how parameters work. When you have a parameter, it's basically the same idea as defining a variable with that name and setting it equal to whatever was being passed in. And so in this case, on line 9, we have the getGreeter function, and we're passing in Rosalind. That basically takes us to line 2, which then takes us to line 3, which says, once again, this code is not run. I'm just writing as a comment here so you see it. But underneath the hood, what we're basically saying is, hey, let this variable name equal Rosalind. And then we return our anonymous function that its console logs out hi name. And so this works the same exact way in the previous page. The only difference here is just to let you know that, once again, because we are dealing with functions, we treat these functions like we do any other functions. They are still able to take in arguments and convert them to parameters. And if both functions take parameters, well, once again, right, there's really no difference as long as we can kind of logically follow what's going on here, right? Here on line 4, here on line 8, sorry, I invoke the getGreeter function. I pass in Marie as a name. So within the confines of the getGreeter function, the variable name 1 is equal to Marie. And then I return function, and I pass in name 2, which console logs out hi name 1, meet name 2. And then on line 9, when I invoke greeter, that's the same as me invoking the function from lines 3 through 5. And so when I invoke greeter, that's the same as me converting name 2 to Rosalind, right? And so when I do that, on line 4, when I console log out hi name 1, meet name 2, I do hi name 1. Is there name 1 in my function scope between lines 3 through 5? The answer is no. So I look to my parent scope, the getGreeter function. Is there a variable called name 1 between lines 2 through 6? And the answer is yes, there is. It's a parameter that we provided on line 2 there. So then name 1 becomes Marie, and then comma meet name 2, and name 2 is just passed into us as Rosalind. And so here we write hi Marie, meet Rosalind. Okay. So this is the last slide, and I just kind of want to, I know it can be a bit confusing, so I just want to kind of make sure we walk through it kind of as a group. On lines 1 through 5 here, we have the same function that we saw before, right? It's still the getGreeter function. It takes in name 1, it returns a function that when you invoke it will take in name 2, and it will greet name 1 with name 2. The main difference here is on line 7 and 8, right? Notice how on line 7 I have this variable called introduce Marie 2. And on line 8 I have this variable called introduce Rosalind 2, right? And notice in both cases I am invoking the getGreeter function, except I'm passing in different values as the argument, which effectively means I want different name ones. This is a very critical step kind of for us to understand how powerful all this can really be, because essentially here what I'm doing on line 7 and 8 is I'm actually creating different greet functions, right? Because on line 7, that function that gets returned to line 7, in that function's opinion, if I look in its scope, it will think that name 1 is always going to be Marie. Hence why we call that why we store it under the variable introduce Marie 2. Similarly, on line 8, when we invoke getGreeter, we pass in the string Rosalind. That is basically telling that greet function that gets returned, hey, from now on, your name 1 is always going to be Rosalind, right? So here you can see us actually being able to create different instances of the same function, just so that we can use different values that were passed in to create it, right? Because introduce Marie 2 was created when we passed in Marie as name 1, and then similarly introduce Rosalind 2 was created when we passed in Rosalind as name 1. And so now on lines 10 through 11 and then 13 through 14, whenever I invoke introduce Marie 2, as far as that function is concerned, Marie or name 1 is Marie, and that goes for lines 10 through 11. And then on lines 13 and 14, because we create that in a world in which name 1 was Rosalind, whatever I put inside there, whenever it goes through and looks for the name 1, it will think that name 1 is always going to be Rosalind. Cool. So, I mean, that was it, right? And like, hopefully this concept makes a lot of sense intuitively. As I said before, this is almost like a way to kind of circumvent a lot of what we learned about scope so far. But notice how even though it is circumventing scope, it still requires the author of the code to, give access to that variable inside that action, right? It's not something that, comes kind of pre-standard where everyone has access to everything. So in this case, even though the computer is, kind of nullifying some of its safeguards, it is doing so by almost like explicit permission from the programmer, because the programmer knows that, hey, this is how Clojure works, and if I want to give you access to these variables, I will, and if I don't, then I shouldn't. So that's pretty much it for all I have for today. Are there any questions? Really? No questions at all? Everyone's good?